Ancient astronomy assumed a concept of the universe proposed by 4th century BC Greek philosopher Aristotle, who imagined the Earth at the center of the universe, with the sun, moon, stars, and planets all revolving elegantly around it in perfect crystalline spheres.
In the 4th century BC, the Greek philosopher Aristotle proposed a model of the universe with the Earth at the center. His model was popular but did not explain planetary motion. In the 2nd century AD, the astronomer Ptolemy provided a solution that kept Aristotle's universe in order for the next 14 centuries.
1st century astronomer Ptolemy improved on Aristotle by accurately tracing the paths of the planets, which didn't move haphazardly after all. Using complex circular motions called epicycles, Ptolemy could predict their prescribed paths and changing velocities. In other words, Ptolemy's system reliably predicted the future behavior of the planets, another step in man's journey to understand and control the universe.
Long before the scientific revolution, Claudius Ptolemy proposed a model of the universe in which Earth was at the center. All of the planets, including the Sun, revolved around the Earth in uniform, circular motions. Each planet was also on a secondary orbit called an epicycle. Planets revolved around their epicycles and around the Earth simultaneously. This demonstration provides a simplified general idea of Ptolemy's model of the universe. Though Claudius Ptolemy's model of the universe was not completely accurate, he was a brilliant mathematician who provided relevant information for astronomers in the future.
Soon, an unprecedented eye in the sky will open a window on the creation of the universe. The Webb Space Telescope will rocket 1,000,000 miles into the void. The Webb will replace the revolutionary Hubble, allowing us to see through space and time. The Webb telescope will look backward nearly 14 billion years, giving astronomers a glimpse into the secrets of creation. Strange as it seems, this lofty arc began only 5 centuries ago, when a Polish monk peered into the sky. His theories would spark the scientific revolution and launch mankind on a fantastic voyage of exploration and discovery.
Discovery, roll program. To roll, Discovery.
Since the dawn of civilization, man has gazed in wonderment at the skies. The end of the Middle Ages brought a revival of classical learning. Striving to explain human nature, intellectuals embraced the scientific method of observation and questioning. As they focused on the movement of the stars in the heavens, astronomers began to replace mythology and magic with hard science. One of these stargazers was a Christian monk named Nicolae Copernic. We know him as Nicholas Copernicus. His vision would set the scientific age into motion. In their studies of the stars, astronomers had long struggled to explain what they were seeing. What caused the sun to appear to travel east to west each day? And why did the planets seem to track eastward across the zodiac? Nicholas Copernicus reasoned that the Earth might spin, causing the sun's flight. And if the Earth moved in a circle around the sun, that would explain why the sun seemed to travel across the zodiac. In so many and such important ways, then, wrote Copernicus, do the planets bear witness to Earth's mobility. In the spring of 1609, Galileo Galilei stood before a new marvel, the spyglass. Galileo was a devout Catholic, but he was also an avid scientist. He improved this new tool by grinding lenses that increased its range by a factor of 30. With his telescope, Galileo looked further into the night sky than anyone before. He saw craters dotting the surface of the moon and spots on the sun. Galileo saw moons orbiting Jupiter. He observed Venus moving through phases much like the Earth's moon. This information persuaded him that Copernicus was right. Just as Jupiter's moons orbited that giant planet, other planets like Earth and Venus must therefore orbit the Sun.